All right, guys, today we are going to be working on a lab. The lab is called a qualitative analysis lab. We learned earlier in the year that there are two types of analysis. You have quantitative, which is dealing with numbers, and we have qualitative. So generally we say that qualitative is not the best type of analysis. We prefer to have numbers because it's easier for other people to either agree with what we got or disagree because we're all seeing the same things. But when you start using description, that's not the case. However, there are some ways that we can set up qualitative analysis in a manner that is actually pretty accurate. We can get some good data out of it. So the way that we're going to do this is we're going to use some qualitative analysis to identify some unknown chemicals. All right, so the way that we do this is because it is qualitative, you can't just look up data in a book. You are going to have to do the reactions yourself because somebody else's definition of orange might not be the same as your definition of orange, right? And so you need to have your own perspective in order to compare. So what we have is a sample, it's a fake data table, right? And so we have some different chemicals and we're trying to identify what those chemicals are. So maybe let's just, for the sake of making this understandable, let's say that this is pollution, right? So these things are our pollutants that could possibly be in a lake or something like that. We want to know if they're there. So a chemist goes out to a lake, they take a sample of the water and they bring it home and they want to know if these things are there. That would sort of be our unknown, right? When you go to the lake and you get that sample, there might be some unknown pollutant in there. And what we're testing for is one of these four things or multiple things. The way that we do that is we say, all right, well, let's see what happens when I react these different pollutants with these ions. And so we have a little combination table here and we start mixing. So we take a little bit of this pollutant. So I go out and I get it. Maybe it's lead, maybe it's mercury, maybe it's whatever. Except these are negative, so lead and mercury wouldn't work. Let's say it's nitrate or phosphate. Those are common pollutants that we find in water. Nitrates and phosphates are from fertilizers and things. So let's say maybe our lake is full of nitrate. Let's test and see what happens if I take nitrate and I mix it with these different things. So I take my pollutant, I mix it with number 1, and you see that we wrote NR. NR stands for no reaction. It doesn't seem like anything is happening when we mix these two things together. But when I mixed the pollutant A with number 2, I got an orange PPT. Now, what the heck does PPT mean? PPT stands for precipitate. Now, we've all heard this term precipitate before, but we might not know what it means. Like, for example, if it's raining, the weatherman might say, oh, expect some precipitation today. Precipitation is when something changes phases. So if it's rain, you have a bunch of different things in a liquid form that is coming out. So it wasn't a gas, right? All this water vapor was in the air, and the water vapor precipitates out into a liquid form. Well, in this example, we're going to have things that are in the liquid form, and it's going to form a solid. So this is basically forming an orange solid, and then when I mix the pollutant with number 3, we get a green solid that forms. Now, it's not going to be like a solid chunk that falls out onto the table. It's going to look muddy. It's going to look like muddy water, basically. Then we do the same with B. We mix it with those same things. We do the same with C, and we do the same with D. Then we say, all right, now I went and I got my sample of lake water. And so now I'm going to take my lake water and I'm going to mix it with a little bit of this chemical, and nothing happens. And then I'm going to mix it with a little bit of this chemical, and nothing, and I get a yellow muddiness. And then I'm going to mix it with a little bit of this one, and I get some blue. All right, now what we want to do is use these observations and compare them to what we got up above, and we can go ahead and see what we have. Now, you're not always looking for perfect matches. Sometimes ruling things out are more valuable, right? So for example, in number 1, I see NR. And so some people go, oh, NR, that's this. Oh, or maybe it's this. Oh, wait a minute. Or maybe it's this. Right? It could be any one of these, right? But what if it's not even any of those, right? What we have that's valuable is when I added this chemical, I did not get a white PPT. So I know for sure that B is not present in my lake. If B was there, then when I added this, I would have got some muddy solid that formed. Okay? So that's the first one. Now, when I move over into the next test, so at this point, I'm basically saying, all right, I've ruled this out. I can kind of pretend like this isn't even there. It removes things from the board for me. So I move over into equation number 2 now. I added it and I got a yellow PPT. So if I get a yellow PPT, I'm having a little trouble ruling things out, right? Chemical C could be there, right? It could be there because I got no reaction here. It also could be there, but I just can't see that because there could be multiple chemicals present. So I'm having trouble ruling things out, but I do see this yellow PPT, so I'm feeling like it's probably some D that's present. Okay, but I don't know for sure because the orange and yellow, those are kind of close. We keep moving and we see a blue PPT in number 3. Now that's pretty distinct, right? So if I have a blue PPT, then I'm guessing then it's going to be letter C. All right, so in this situation, we're just still trying to figure out what we've got. So at this point, probably because of the yellow, I'm going to say that we don't have too much. If I have the blue and the green, I'm guessing that A is not there, right? We would have just seen something show up. But I have the yellow, I have the blue. I ruled out the presence of this guy here. So we're going to go with C and D for that one. That's what I would say is in the unknown. Okay, now I want you guys to try one. So we're going to start over. So somebody went to the lake, and instead of this chemical, maybe they went to a different lake. Okay, they went to a different lake, and this is the chemical or the observations that we got when we tested that chemical. So hypothetical unknown number 2. We have a white PPT when we added number 1. With number 2, we got nothing. And with number 3, we got yellow. So do we have 2 things there, 1 thing, 3 things? What do we got? What do you think? So if I was doing this, sometimes it's not necessarily the easiest thing to start with one. You could jump around, you could move around wherever you want, but this one seems pretty easy. White PPT, the only thing that will form a white PPT is letter B. So I would definitely say that we have letter B for sure. So I'm going to write that down. I think that there's some B minus present because of a white PPT with Roman numeral 1. Okay, so I think that's for sure. I think B is present. So I'm going to circle that one. So now we move over into number 2. There's no reaction. Nothing happened, no PPTs. So what does that do for me? Well, there was a PPT here and here, and that didn't happen. So I can rule out A and D for sure. So which are absent? A and D. No PPT with number 2. Right? So I was able to rule those things out for sure. So now I just have to decide, is there any C or not? And if I look in this last one, I got a yellow PPT. And C would have given me a blue PPT. And And so if blue, so we already know the yellow should be here. And so what would have happened if blue was also there? Blue and yellow would have made like a green color, and we definitely don't see any green. So I'm thinking that there wouldn't be any C either. So I'm going to say that A, D, and C is absent. Wrong color. It would have been green. So run out of room there. You guys get the idea. I don't think we need to do any more. So this hypothetical number 3, we don't have to do this one. Okay, so you can skip that. Now what we're going to do is we're going to do this for real. Okay, I am going to do it with real chemicals, and you guys are going to try and identify. And so down below here, we have the same type of thing. What did you find? And explain why you think that it's those particular items. Now there are 2 unknowns that we're going to do. So right now there's only space for 1 here, but you'll kind of want to maybe split this in half so that you can take observations for 2. Boy, that was a crooked line, wasn't it? Let's do this. There we go. So we could split that in half. But what's going to happen now is we're going to switch over to the camera, and I am going to start mixing these with these. And you're going to want to record what you're seeing in each of these boxes. So that would mean you either need to print this out and fill it in, or I guess you could use Cami if you're really good with Cami and your observations, that's fine. But keep in mind, if you are going to use Cami, when you get down to these conclusion questions here, you're going to be writing the formulas that were produced. So AG was mixing with 4 different things. So you're going to give me the formula for AG with Cl, AG with SO4, AG with CrO4. And when you write your formulas, I don't want to see things like this, AgCrO4. If you're writing formulas, that would need to be a subscript. Okay, I want things shrunk down properly. So if that takes too long, then print this out and write on it and then just re-upload it. Okay, but it's got to look right. That being said, let's switch over to the camera and we are going to start mixing. Remember that your unknowns, you're looking to see which of these things are possibly in those unknowns. So I'm going to be adding this to the unknown, and hopefully you'll have, I would guess probably 2 things in each unknown. So that's what we're looking for. All right, so let's go ahead and put it into practice now. The chemicals that we are really using across the top, we are going to be using some silver ion. We are going to be using barium, and we are going to be using zinc. So instead of the hypotheticals that we were seeing on our paper, these are the actual chemicals that we're going to be using. Down the side, we're going to have chlorine, sulfate, chromate, and then this is iron cyanate. And then we're going to have a couple of unknowns that we're going to analyze and see what we can do with that. So let's go ahead and put some of the chemical down. And we'll make some observations here. So we're going to go ahead and put the chlorine down first. And so I have some black X's just so that it helps us to kind of figure out if we could see anything. So I'm just going to put 2 drops of each of those. And then I'm going to go ahead and do the sulfate next. And then we've got the chromate. See, the X helps us to see if something's actually happening, because a lot of times people will see this one here and they say, oh, it turned yellow. Well, it was already yellow to begin with, but you'll notice that while it's yellow, see how we can see the X perfectly clear through all of these things? So we know that nothing has happened so far. Let's move on to the last one here. This is the cyanate. Kind of yellowy as well. All right. And so now we're going to go ahead and start the equations here. So we're going to actually start the chemical reactions. We're going to put a couple of drops of each one in here. So we've got some observations that we could make there when silver is reacting with the chlorine, the sulfate, etc. We're going to go ahead and take a look at the barium with each of these things now. And then the last one. So we've got each of these. So like when we look at something like this, we mixed it. It was clear before, still crystal clear, versus this one, we can see that something must have formed in there. There's like a solid that's formed. This is a precipitate that we're seeing, and it's made more visible by the X being there. So let's go ahead and try an unknown. So we've got two different unknowns I want you guys to identify. The first is unknown number 1. So we're going to record number 1, and I'm going to put a drop. Okay, so we've got the unknown number 1, and now that it's going to basically be, we know that it's going to be a combination of a few of these, right? Maybe 2, maybe 3. So we're going to add our reagents to see what it could possibly be. So let's go ahead and put some silver in, see if that's there. All right, so we see that I got kind of white and foggy. You see something happen there, and then the last one. All right, so we've got our observations for unknown number 1. And now we're going to do an additional one. Let's try unknown number 15. Okay, so we're going to go ahead and we'll just put it off to the side. Maybe I'll put it over this line there and make it a little easier to see. Okay. So we'll go first to the silver. And then we're going to go to the barium. And then finally we are going to go to the zinc. Okay, so we can see our chemical reactions for unknown number 15. And we can see our chemical reactions for unknown number 1. And now it's going to be your job to try and identify these and finish up those conclusion questions. Good luck, you guys.